Welcome to D Technology. As an ANSYS channel partner, we provide simulation capabilities in the areas of fluid dynamics, structural mechanics, electromagnetics, and systems and multiphysics. D seldom supports ANSYS software in the central United States. We also provide consulting and training for the entire ANSYS software suite. Our mission is to help clients maximize their utilization of ANSYS software to the highest degree possible.
Here we have a beam and shell compatible model. We have some square tubing, some C-channel, an L-angle bracket, and a flat plate sitting on all of that. These are all separate parts. You can see all the solids here. I'm going to use the SpaceClaim beam extraction tool. Under the Prepare tab, there's this extract option. Just highlight all of them. And SpaceClaim will convert those to line bodies automatically for me, place them as beams in the tree here. And then we'll extract all the profiles for those cross sections automatically for me. So if I click on this one here, you can see I have the area and centroid and moments of inertia and so forth extracted. Now, what you'll notice is that the cross sections don't quite line up on the same plane, so we'll go ahead and fix that real quick. You can use the Move tool. That puts them all on the same plane. The beams don't quite line up at the corners here, and same thing here where the C-channel meets with the L-angle bracket. So we can fix that with this Create Corner option, and we'll just click on two beams. You can see the corner is made there. I'm going to use this option for the C-channel to L-angle brackets. Okay. So all my beams are now created. You can actually show their cross-section using this option here. There's my C-channel, my L-angle bracket, and my square tubing. The flat plate here, we need to mid-surface. You can easily do that with this mid-surface option here. Select both sides, they'll turn blue, hit the green check mark, and now we've converted the solid portion to a surface geometry, which you can see in the middle there. And then same sort of thing, it's not on the same plane as the rest of the beam geometry, so for simplification here, I'm going to do the same thing, just move the plate to here. And then at that point you could bring this into ANSYS for analysis. One last step we're going to do here is we're going to highlight everything, say move to new component. This is the equivalent of a multi-body part in SpaceClaim, and then we can change the share topology option to share. Jump over to ANSYS. Once we're at the project page, just going to do a simple static structural analysis. Jump into the mesher. So here's our beam and shell model. You can see a single component or single multi-body part. If we take a look at cross-section solids here, you can see our cross-sections inside mechanical. You can see our plate actually sits in the center of the beam geometry here. We'll fix that here in a couple seconds. Real quick, just to show the mesh. There's our mesh. You can see the nodes actually line up where the line bodies touch the plate. And show thick shells and beams, and we can see the same sort of thing. The plate is sitting at the center of the beams. That's not physically correct. and that's altering the stiffness of the geometry, so we'll go ahead and fix that. jump back to the mid-surface in the multi-body part, and we can modify this offset type here to be user defined. Change this to inches. And then if we look at the mesh, we can see that plate now sits on top of the beams. And just as a real quick analysis, I'm going to go ahead and fix the bottom of the upright beams here. Also apply a pressure load on this group of faces. Actually use extended limits here. And then say -1 psi here. Solve this real quick. It's a very quick analysis because the model is very simple, beams and shells. If we look at deformations, there's the beam and shell demo.